Ever wonder why generating a 5-minute AI video feels like waiting for a glacier to move? Let's break it down. Imagine trying to assemble a 1,000-piece puzzle, except every piece has to communicate with every other piece. That's essentially what traditional video models do, and it's incredibly slow. But here's the twist. A breakthrough called Radial Attention is rewriting the rules. Let's dive into how it works, and why it's a game changer for AI video creation. The core issue lies in how AI processes video. It breaks footage into tiny units called tokens. Think of them as motion pixels. Traditional models use dense attention, where every token converses with every other token across all frames. Picture a chaotic party where everyone shouts at once. The problem? The computational load grows quadratically. So a 500-frame video isn't just 500 times harder, it's 5,002 times harder. That's why generating even a short clip can take hours. Enter Radial Attention. This innovation draws inspiration from a simple physical principle. Energy fades with distance. Like ripples in a pond, where waves lose intensity as they spread, Radial Attention assumes tokens have less influence the farther they are in time or space. Instead of checking every token against every other token, it zeroes in on the most relevant ones, like a spotlight instead of a floodlight. Here's the math behind the magic. Radial Attention reduces computational complexity from ON2 to ON log N. For a 500-frame video, that's like cutting a 10-hour movie into a 2-hour version, without losing the plot. It also slashes training costs by up to 4x, making AI video creation faster and more energy efficient. It's like swapping a gas-guzzling car for a hybrid, same destination, way less effort. Let's imagine editing a bustling city street video. With dense attention, the AI would obsess over every detail. The reflection of a neon sign on a puddle, the texture of tree leaves, even a distant flickering light. Radial Attention takes a smarter approach. It focuses on the most critical elements, like a pedestrian crossing the street, while letting less important details fade into the background. The result? Lightning-fast processing and videos that still feel vivid and real. But how does this actually work? Radial Attention uses a static mask, a preset pattern that guides the AI's focus. This mask acts like a radial gradient, narrowing as it moves away from the center. For example, in a video frame, the AI pays full attention to nearby pixels and frames, but gradually blurs out details that are farther away. This reduces calculations without sacrificing quality, like using a zoom lens to focus on the subject while keeping the background softly out of focus. The results? Radial Attention outperforms older methods like SDA and PA in key metrics. In tests, it achieved higher PSNR, a measure of clarity, and better vision reward scores, which evaluate realism and consistency. Imagine a video where a golden retriever's fur glows in sunlight, grass sways naturally, and the scene feels authentic, all while the AI works 4x faster. And the benefits don't stop there. Radial Attention's efficiency means creators can iterate faster, experiment more, and bring ideas to life without waiting hours for renders. It's not just about speed, it's about unlocking new creative possibilities. So what's next? If AI can now generate videos that feel real, we're looking at games that adapt in real time, virtual reality that feels like a dream, and even movies written by algorithms. But this isn't just about flashy tech, it's about making AI practical for everyday use. Next time you watch an AI video, remember, it's not magic. It's math refined by clever techniques like Radial Attention. And as this tech evolves, the line between human and machine creativity will blur even more. Stay curious and keep exploring the future of AI.